Hello. In this video, we're going to continue creating our web server that we already built some part of it in the last video. In this video, first I'm gonna try to make our code a bit more structured, and then I try to make it async. So in the last video, if you remember, we did we had parsed method URI version from the HTTP request and headers. We didn't do anything about the reader, the body till now. So, but we want to make our users be able to read the request body themselves, and we do nothing by default for them. So the same interface, for example, Go that gives people on their request, it will parse the other metadata out of the request, but the query arguments and in some libraries path parameters and also the body. So we didn't handle the query parameters and path parameters and the body. We need to handle these three. I will start with creating a, so let's start. So I will start with creating a request struct. Let's say struct. I already told you that in Zig, everything is value, everything is data, even types are data. So what should our request have? Our request should have method, which is a type method. We will define this later. It also should have URI, which is of type string. And version, which is also an enum. And headers, which is a standard.string hash map of strings. So string hash map is basically hash map that its keys are already strings and the value is also string, and it's only generic over the value. So we also have some kind of body, which is a reader, right? But what is the reader type in a stream.reader? What is that? Let's see. So stream has a reader, right, which is a public, so we can access it, and it's a type like this. Okay, this is really cool because we can just call that net.stream.reader, which is a type. We also need method, and method is going to be an enum, has get like this, post, put all HTTP available verbs or methods. Put is not add this patch, get, post, put, patch, option, and I think delete are HTTP methods. I also want an enum for version, which is HTTP 1.1, like this. Can't we do this? Can't we do this? Can we do this? Oh, yeah, I remember this syntax from here, I think. Let me just make sure that it is what I think it is. Not external. Externs are probably for C stuff. Yes, CABI stuff. Extern enum literals. And do on off. Didn't give me any. Okay, didn't give me any help, but I've watched some streams on Zig and I know that I think that this syntax is valid. So for now, we would say HTTP2 is also supported, but we are only going to support HTTP 1.1 and not the other ones because we don't have them yet. You know what? Let's just ignore these. Yeah. So version is either 1.1 or 2, and we got the methods. Okay, method, version. Seems good to me. So let's create a request. So in here, you know what? Let me just do some kind of, I'd rather say public function debug print. I don't know if there is something like Golang fmt.stringer interface. I mean, some kind of some way of printing to defining how an object should print itself, or how an object should represent itself as a string. I don't know if there is something like that. Okay. Yes, and this is void now. But std dot, is there fmt, right? So std.fmt.format, parse, format text, parse, font slice, format, alignment, format, default, I don't know, font duration, what are these? Format type, I don't know. So for now, let's just have this. I want to be able to debug this. Can I make this a bit smaller? Okay. And I will add these into here. Okay. And this should get a request. Say pointer to a request. So it's of course self.method, self.uri, and self.version. Headers is self.headers. That's it. Yes. Let's also create a function for these from string called nothing, returns a method, passing just a string, which is constant u8. Let's do, can we do switch on these? I want to do a switch case on std, on equality of these with the string representation. So as we saw in the previous video, we should use stdmem equal eql. That will take a generic parameter of unsigned 8-bit integer. I want this to be get, and also with yes. And if it's true, I want to return a get, represent get and get method. And you see that I didn't specify method.get because Zeek can infer the enum type as well like the struct type that we saw in, for example, here, I think. Yes. In here, you see that we didn't specify anything. Zeek compiler can infer and generate the necessary code for us. Make this post, make this put, patch, option, wanna delete, and we do post, put, patch, option and delete. And this should return an optional. It can return an error or an optional. I would rather say an error, actually. So what error should we return in case that none of the above conditions matched? So let's see how actually Zeek errors are created. So I think it's here. And by the way, this is the Zeek specification document. So errors. Error set is like an enum, yes. So we can create an error set exactly like an enum. They're basically enums, I think. I don't know why they created parsing error. I would rather say error. I don't know why they created a new thing. I think they could handle it with enums. I don't know what's the reason. But for now, it's method not valid. And in here, I would return a parsing error dot method not valid. Okay, I did some wrong shortcut. Method not valid. And this should also do. Are you going to do this in correct way? I mean, is Zeek function returns? Can we, will this just return the last expression evaluated in the function? Like functional languages? I don't know. Let's actually take a look at the Zeek learn as well to see if this is how this works. Functions. Oh, it didn't, it's not saying anything about this. So I would go with the safe way of just returning the expression. And also note that the switch, for, while, all of these, and also I wanted to say another thing. Switch, conditionals, if, while, for, and almost everything are expression in Zeek. In Zeek, everything is an expression. So switch expressions have a value. Whiles even can have values, and maybe we see them, I don't know. Well, we know that switch is an expression, so the output of this switch expression is our return. So let's do also with the version, almost the same thing, from string as constant u8. And this is also going to fail for some reason. And let me add version not valid. Come down. Same piece of code, basically. How is this version is send HTTP Wikipedia? Let's see how this is sent to the server in the request payload. Oh, okay, this is the syntax. Come back, paste this, and probably the 2 is just like this. I hope so. And the version we return 1.1 and 2. Cool. So, and this is version not valid. So now we can create our request from what? You know what? What this is doing basically is just creating the request things. So I will say init, I will take the allocator and also the stream, which is net.stream, and I would return a request or fail. And I would basically just cut everything into here. Hopefully this will work. There are a lot of unused constants, errors, and this is actually problematic. I think for the better experience, I don't know, because this is actually the compile error, so it's not formatting, and I think it's reasonable. Okay, so since we need to return a request, I will return a pointer to a request. I don't know what's better to have. Let's work with the request itself and not allocating anything unnecessary. So I will return a request. Right. So what our requests have is that headers is headers dot method is try of method dot from string method. Same goes for version. Headers method and version. There's the URI, of course. URI is simpler. It's just URI. Okay, so what other things we have? We have body. So the body is just a stream.reader that we already have. But how is this? So you see that sorry for the disruption again. My phone just kept giving me notification sounds. So where were we? Oh, okay. So we were okay. So when we start parsing the request, we have a we have a reader on the request from the starting byte, right? And the reader is stateful. Okay, so when we start reading line by line, as we have in these codes in here, we read the first line, we get method URI version out of it, then we read headers, all the headers. When we reach here, when we reach this, there was an if, yes. When we reach this if and we break, the next line that this reader is going to read is from the body. If there is any line left, it's the body. So if I put the exact same reader object in the request payload, the user can put, I hope that the user can read, I hope everything that I'm assuming is right. The user can read from it. I hope. What is this type? It's a reader. What's a reader? Reader is this. And this is just some type. I'm a bit skeptical because I'm hoping that this reader does not get cleaned or anything. Not cleaned. Zeek doesn't have any GC, but if it's a pointer, it might get out of scope. I don't know. Let's go with this and let's hope everything works. Otherwise we should put maybe just put the stream itself into the request. Let's actually just do that. Instead of this, let's have a stream field, which is net.stream, and also public function. I'll say body returns a net.stream.reader. And this will return self.pointer to request, and this will return self.stream.reader. Yeah. and this is string. So we create the request. We have the string, we have the body, and I will actually, this is not a request anymore. This is actually, since we have the stream inside the struct, it's actually more of the context of the whole HTTP connection. So I would rather call this HTTP context instead of request. Yes. Do the same thing for this, and this. Run this function parameter, which is here. Okay. So now, yeah. So now this handler should create the HTTP context as the allocator and its stream. This will give him, with a try, this will give him an HTTP context. And now in the HTTP context, we can actually hope that we can write, right? So there's this body reader. There's also response. And the response of an HTTP is basically writing onto this socket. So if I have the same HTTP context, I should get a stream writer. Is there such a thing? I hope there is. I hope there is. Oh, I think my LSP is starting to crash. Can I go at least here? No. Maybe I should restart my editor. Will you work now? Okay, I don't know what happened. I really don't know what happened. What's wrong? Unused local variable. This is not used. Maybe that's because why everything is not working. Let's try this now. This is still not working. Why? We already did use some of these. Will you work at least? Okay. So net.stream.writer, which is this. I really don't know what's wrong. Let's actually try to compile this code. I think it will give me a lot of insight of what's wrong. So zig build run. Unable to evaluate concept. Oh, this is actually, I don't know what's this problem that this has, but Zig compiler, I think, has a problem because it's trying to evaluate this expression and make basically this function as a comp time thing. It thinks that it can evaluate this, and it can't. So you see, it says I cannot evaluate this S, and this is right because we should pass S to you in the runtime. But it's trying to do it in the compile time, and this is an error. So let's just make this work for now. So we do an if. I don't know how to fix this. I have no idea. And make this semicolon. Yeah. Make all of these ifs. And okay. So in the case of anyone, we return these, otherwise we return this. We should do this probably for this one as well, but let's try that. Yes, the same thing happens in here. I don't know what's this bug, but it's annoying. So let's do if this semicolon in here and do this return. Same thing in here, return. If for this, it's just return this. Okay, so there's, oh, okay, there's this. I don't know, I missed. Okay, let's try to compile now. It's now actually compiled. So let's make this, and well, everything do this. Okay, so let's http context.debug print, and let's actually make this debug print request. Debug print request. Let's see what would happen. So let's, I think I have the curl in here, right? So I have this, call this, we get a crash. Version is not valid. Why? What's the version anyway? So let's see what's the version actually. Print. I remember from last night that I should put this as when I'm going to print. Let's run this again. Run this again first. Go. Okay, I didn't do anything. Why you crash? Address in use. Oh, that's the problem I was telling you. For some reason, it don't clean. It don't. It's not stop listening. Okay, let's try this again. Give us the crash. Version is not valid. This is the same version, dude. Why is there an error? It's saying that this is the version. HTTP/1.1. And it's saying that these should be equal. You know what? We should compare these byte to byte, because byte by byte, because maybe there are characters I'm not seeing in the terminal print. So I would say any, and I will pass this, and I will copy this in here, put this in here. Let's see if this works. So what are the bytes? Okay, it's 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why we have the 13 thing again? Didn't we skip it? So 13, as you remember from last night, the 13 from the previous video, 13 is the line fit character, not the line fit. It's the carriage return character. But I thought we skip it in this slicing. So let's see how slicing works in Z. Maybe it's inclusive, not exclusive. It says that xn to m is starting at n and ending at x m minus 1. So it's exclusive. So right, we should -1 this because we want to skip an element as well. Right? Am I right? Yes. We get the version, we get the method, we get the URI, host, except, and the user agent is this. So we got all headers, methods, and everything. Cool. So let's remove these two prints I have. Now, so this is actually, so now what we should do, so we have this. Now what we should do is, okay, so our handler takes in these. Now we should do something with the response. So we should return a valid HTTP response. Then we could start trying to make this async. So let's see what is an HTTP response looks like. Okay, so it's the same. So there's a status line consisting of protocol version, space, response status code, empty reason phrase. Okay, zero or more response headers, same, empty line, message body. So let's write this. So in the HTTP context, we already have a response that is a writer, but I want a more, high-level API, as you would say. So I will have a respond that will do HTTP context, and this is a void. So let's do this. So I will get the writer. Writer is self dot. Actually, you know what? I can call this response. Now on the writer, I will print. Print is just like the print of std debug print we are doing in here and here. Sorry. And also, but it does the write on the writer. So we had a first line, and the first line was version space. Can I see column again? Okay, version space status code space some I didn't understand what is this. A response status code, another space, a possibly empty reason phrase. Possibly, maybe it's not there, but since we are generating the response ourselves, it's okay. I will always put that in there. Then a carriage return and a new line. Next line we have the response headers. So I will pass response headers, which is also string hash map, right, and the body, which is string. So next, okay, so we write these under response. This can fail, so we try this. Then we go for the writing of the headers, and I have already the code in here that I can paste right in. Headers is not self anymore. Headers.iter, iterator, headers.iter. Okay, every time just do this on writer. Basically, that's the same format, right? Yeah. So do this. This will print our response headers that we want to send to user. I want to make this an optional. Maybe maybe I don't want to send any response, but no, let's just have this. No, because if it's not there, the user should allocate just empty hash map, because Zig's value cannot be null by default. So making it an optional, it's probably a better choice. Headers, if headers dot, should we do this, or how we should handle optional values? I don't know. Let's see. So how we should handle these optional stuff. Let's see. Optionals. We can do these, or we have an or else. Can we have some if over them? Yes, this is what I want. So if headers, then there is the capture syntax we already see in the while here. And let's make this headers. Let's change this name to be maybe headers. Maybe headers. And put these inside here. Okay, what I'm doing, I don't know. Maybe headers. Who's shadowing who? It says that I'm shadowing the declaration of body. Where is body defined? Oh, okay, here, the method. Is this an error? Okay, it's not a good error, I would say. But let me change this for now. So body reader. Now, and finally, we should do writer.print, not .print, .write body. After, oh, okay, after headers, we should do writer.print an empty line. Okay, let's try to build this again. Okay, for the weird reason it's working, which is weird. This is working. Okay, this write needs a try. Okay, how? Oh, I think zip compiler is basically skipping my code since I didn't call it because these were compilers, right? Or no? I don't know. Maybe this is, since I didn't catch the value, it's not a compiler. Okay, anyway. So now I want to send a static response for now. So I will use my respond higher level API. I don't pass any kind of headers. And I will just pass body hello from Zik. And I will also do a try. Let's run this again. We got error. Expected 3 found 2. How? It's in here. Okay. Yes, we should pass self dot. What was the first one? It was the version. So version and status code. Okay, so we should pass status code, which is a usize. Or no, actually, let's make this status, and it's a status. So let's make the another struct, another enum. Should be this. Should be an enum, right? I think. So for now, we would only have OK. We also have string, or maybe as string, and this return a string self status, return if self equals status.ok, return OK. Use of undeclared identifier status. Okay, you're just here. Okay, we are there actually. It's an enum. And should I do this? I have seen some of this. Let's see if this works. I will explain to you if this compiles. Okay, where is the... Okay. Unused function pointer? Okay, not here. Oh, I think I've found the problem. This is status again. This is status again. Yes. So the problem was missing semicolon. And okay, so I have the status. On the first line, I should get the version, the status. Okay. So we need another one, which will as number, I would say. This will return the number representation of that status, which is 104. Okay. So self dot status dot as number, self dot status dot as string. Let's compile this, giving an unused function parameter. Which one is unused? Oh, no self. Sorry. It's not a self. Okay. Okay, we get expected type is status, found type null. Okay, the calling is wrong, of course, because we need the status before this. So status dot okay. Another error is ignored. Yes. Where is this? In here? Try. We should pass the empty tuple because it tries to format this. Maybe, no, not this one. Expression value ignored. Okay, really? Oh, okay, yes. So right returns some red. So right returns how many bytes it's have been actually written on the socket. Cannot format without any specifier. Where is the code? Where is the problem? Called in trying to print. Okay, in here. Same problem as always. Sample version. What is a sample version? Oh, we should have some similar thing for version as well. Public for an string gets a version, returns a string. If self equals version dot this, return HTTP 1.1. Otherwise it's 2. Okay, another error. Okay, we still have this error because now version should also be as a string, as number. Number shouldn't be, this should be. Okay, another one. Found void. How you found void? Oh, okay, because we didn't handle the base case, which is not returning actually. This should be, since it's on the self, it cannot reach here. So I'm gonna do something nasty. I think it works. Yes. So unreachable basically for Z compiler means there is no way that my code reaches here. And this is actually, I think, correct because we are defining this as a string as a method on an enum. Enum should be one of the available fields. So if we run this, again, cool. we actually got a valid HTTP response, and let's actually do -v, so we get everything. So we have the response headers. Are these response headers? These are response headers, right? So we got the response header. This is the line. Okay, so I think this is a problem. Maybe we should some way we should close this. This is actually closing it, isn't it? Can we do anything on the writer? Is this a thing? Let's go into writer, and it's not working because, you know, new language tools are not as good as they should be. Is there any close? No, there isn't. So I'm gonna say this is actually cool. So what we did in this until here, we actually made it possible for our handler so to respond to requests in a, I would say, good way. So we create an HTTP context from the request. We just do a print of it, and then we try to write it. Right. Next thing is going to be making our code async. I'm gonna bring some water and come back. Let me pause the recording. Okay, I'm back. Sorry for the disruption. Let's continue. So we wanted to make this async, right? I have written some async stuff before. I opened this right now, and I wanted to take a look and cheat a bit while I was drinking some tea. So we have the suspend and resume. This is the low-level API basically, and there is an async await way of doing stuff. So each async function should be awaited. But you know what? I think we don't need await, because our async functions are going to finish themselves. There's no return value. So what is our async function? Our async function is basically this this handler. This is the async function we want, and this will close itself. This will finish itself. There's no return value. So we just need to, where's our main? We just need to call this as an async function. So this is basically it. But there is a point. Async, when you call async in Zig, it will return you a frame. What is a frame? Frame is basically the whole memory space, I think, memory space that the async call is needed when it's going to be resumed. So async call will start line by line. When it reached some suspension point, a point that it should wait, it will give the control back to the caller, and it will wait until the event loop of the language wakes him up and say, okay, continue until the next suspension point. Basically until you either you should wait again or just return everything. Not, I think, to wait again. I think it should, a wait will make it return value. A wait will block until the async is done. So if we don't capture this frame, I think it will be cleared out after the function. Oh, okay, I understand why. Because after this while, this is a while loop, right? So every time this loop goes, we are basically rewriting the frame. So we're making the async basically does not work. So we should store the frame of this in somewhere, so we have the data and it's not overwritten. So the simplest form would be to have this frames as an array list of frames. Okay, in Zig, every function that starts with @ are compiler built-ins. They are basically things that compiler will evaluate in the compile time, and basically it will generate some code in there. So @frame will give me the frame type of the function, and my function is handler. So this is an array list of these frames of the function handler. We should init this and pass the allocator. So in here, I should do frames dot append, I think. This. So, is this async or not? Is this async or not? How we can make sure that it is an async function? How we can make sure that it is an async function? You know what? We can do some benchmarking, maybe. I don't know. Let's try this out and see if this works with this code now. Okay, we got an error. Error 0. Okay, append actually returns an error. This is valid. One of the cool things about Zig is even when it wants to, allocate some stuff, it's basically an error that you can handle. This is a really cool thing, because in most other programming languages, if the language, either the compiler or the runtime, cannot allocate some memory, it's a weird panic or exception. But in Zig, it's just an error. Run this again. We get error because we have a bug in Zig compiler. This is why. Okay, this is why Zig is not stable. So where is the error? Codegen.cpp we cannot understand, but we know that this is probably the error, either this one line or this line. These are only the two lines we change. We added. So you know what? Maybe Zig cannot. I think Zig cannot create an array list from frames right now. So what I'm going to do is to put the frame in the HTTP context itself. No, we cannot do that. What if we can? What if this handler? Okay, let me think a bit. Handler gets an allocator and a stream. If this is a method on an HTTP context, and then the handler the handler calls init, which is basically the parsing. So I would say parse. Okay, sorry. So I would say parse, call this parse, and returns a new HTTP context. Okay, I really don't know what should I do now. There's another way, of course. Maybe make this init again. Maybe we can create some, temporary type. Maybe a tuple. If I can type, and this would be the same. Can we do this right now? Okay, array access of non-array type. How we can create some kind of a tuple or anything in Zig? Is there anything? Vectors, imports, comp times, unions, structs. Is there any kind of anonymous struct? let's use this. So let's call this frame. Also frame. Again, use of undefined value here causes undefined behavior. So how we can define a anonymous struct? Is there any kind of tuple? Okay, this is what I want. Why it's not working? Oh, okay. Because this is the value of the tuple, and I want add type of another compiler built in, which will give me a type of something expected. Okay, I think we are we are going forward. Expected type pointer to the frame, found constant type. So the frame itself is it says the cast discards constant. Okay, you know what? Let's just create a new struct for this. I don't like to do this, but I don't have any other choice. So frame is frame of handler. It's struct of connections. And I should allocate stuff, I think, for the connection, because I don't want this to be destroyed in the next loop. Allocator connection dot returns the pointer to the con. My code is getting really dirty, but and now the connection might be reference and try to give it some value. The frame of it is going to be this. So there are a lot of problems. First of all, this is this, okay, better. Needs a semicolon, better. Now I should append to this the connection, make this even a pointer, and this needs a try. Let's see if this works. No, because attempt to dereference a non-pointer type. Yes, because create actually create does allocation, and allocation can fail. Whew. Please work. Okay, it's working again. We are at the working state, which is nice. So now let's do some let's do some benchmarking. Do we have AB installed? Yes, Apache Benchmark, right? Yes. Number of requests and concurrency. Okay, so I want to do, for example, 1,000 requests with 10 clients, and the method and everything is ignored, I think, on the HTTP localhost 8080. Test aborted after 10 failures. Hostname, port, path. Why it's okay? I didn't get anything in here. I think the problem is somewhere else. Maybe this is the problem. Yes. Okay. Okay. Let's see. Concurrency level 10. So we did. It was almost, I think, fast. Requests per second was this. Can I see how many concurrent there were 10 concurrent requests. Also why I didn't get any output in here? I should get some output, right? It's weird. Why I didn't get any output? Let me try something. No. If I do curl again, I get. Okay, maybe this is a problem. I don't know. No. I don't know why I cannot use Apache Bench to request this in here. So we have the curl, the method is get. You know what? Let's do another thing. I don't know why Apache Bench is doing weird stuff, or maybe I don't think the code is problematic because curl is working. So what I will do that will probably tell us if this is async or not is to block in the handler. So you see that I can do maybe just in here std.time dot. Is there a sleep? Yes. For nanosecond. Is there a duration or something like go? There was. They were really useful. Time dot timer epoch. Okay, it's really not that useful. I mean, I want. Okay, nanoseconds. Is nano. How much is a nanosecond? I want to maybe wait for 10 seconds, for example. Okay, our connection is really good in Iran, so let's actually read the code. It's probably faster. So we have the sleep, we have timestamp, we have nano timestamp. Oh, we have some. Okay, maybe we can use these because yes, per second. Yes, so I can do std.time.nanosecond per not day per second. 5. So this will wait for 5 seconds. This is wrong. Okay. Sorry. And sleep returns void. So let's moment of truth. We run this. We send a request. It wait. Another request. It waits. I think this is async. But I didn't choose a good way of testing how async it is, because let's do it one more. Okay, 1 2 3 4 5. Yes, it's async because this request took only 3 seconds. But let's make this the Apache benchmark. I really need that to work because I want to, you know, do okay. Okay, the binding is failing. Okay, let the OS close the listening, and while it's doing that, let's see Apache bench this. So we should pass method name maybe. Okay. Apache bench this. Also, method should be get. it's not working. Why it's not working? You know, one other thing that we can do is just do a for loop in. Is this fish? Am I running fish? Oh, sorry. Shell? Yes. So you know what? Let's do a for loop in fish. Oh my god, why internet is so bad? You see here, it does not open anything. Okay, let's see how this for loops in fish works. For I in something can be have a number range. Okay. Fish range. Okay, for I in this. I want this basically. Instead of this, I want to do the curl I did in here. Not the V. Okay. And the sequence is 1 to 100. I want to do the time. So how much time it took for 100 requests is 2.67. Now let's change the code to make this sync again. So basically, instead of doing this and this and this, I would just call my handler like a normal human being, passing the allocator and the connection.stream. Okay, it needed to try. Now let's see. They are the same time. They finish. I mean, yeah, but okay, actually no, because these curl requests are happening in sync. They are not async. Why Apache Bench is not working? Okay, we crash. Error in the probably in the binding, right? Address in use. So I don't want Safari. Apache Bench. Let's see. Is it not sending HTTP1? Okay. Let's try something for the and make this go in the background. Okay. Now it finishes in 1.40 seconds, but it's the sync version, right? So if I now make this async, oh, come on, why? It was working before. I don't know what happened that made it not work. Okay. Run this. Okay, they're finishing at the same time. I don't know how to make these. I mean, I know they're async because I did the sleeping thing. The only thing, okay, let's try another thing. Okay, let's try another thing to make sure that it is async. So the handler for the handler. Okay, you know what? If not here, but I would send something in the URI. Okay, I get what should I do. Okay, with this curl I will send something, a 1. So the URI is /1. So I would say okay, I would send something like exit, and I don't want the exit to do anything, and I want this to, okay, not the exit. If I send sleep, it will sleep, otherwise it should return. So after the initiation of the HTTP context, if HTTP context dot URI, we should do std.mem.equal. If this is, also it needs a U8. So if this equals /sleep, what you should do is std.time.sleep and do std.time.ns per second 5. So basically, and I'm in async mode, right? Yes. So yeah, so basically, if I send sleep 1, 2, 3, 4, 5, it returns. But if I don't send it with sleep, it returns immediately. So we want to test if it can handle one blocking request and one non-blocking. So sleep, you see that it's working, it's async, and then it returned. We can make the actually the sleep more long, so we can 15. Let me actually write that for loop thing in here now. And I want 100 requests. So, oh, okay. So, address in use, right? Yes. I should find a way to fix this, but it's not my priority now. I just want to I just want to demo how async it is. So let's run the blocking version, blocking request, and the non-blocking. You see that it is answering, and it's not yet responded to this one, but it handled, I think, 100 requests. So we created an async web server in Zig. And actually, let me talk about async in Zig a bit, because, and I told you in the previous video how Zig is solving the coloring problem in most other languages. If you want to know what is the coloring problem, you can search. Maybe I put some good articles about it, but basically it says, it means that, so for example, this function is my async function that I want to run in an async context. I don't need to specify it as an async. This is basically not valid Zig code. You see that it's giving me that error. It's not valid because you don't need that. Async functions and non-async functions or sync functions are basically the same thing in Zig. It's basically the caller who calls the function responsibility to call it as an async function or as a sync function. And you see that in here we are calling handler as an async function. So when it blocks and it checks the IO mode, it says, okay, I'm in evented mode. Also, the user called me in an async context. So I should wait till the event loop to call me, to resume me when some specific event happened. Otherwise, when we're calling this without async, or when the IO mode is in blocking, or actually no, when the IO mode is evented, even if I don't call this in an async, it will do async, but maybe we don't. I'm not sure about this, but I know that when we are doing it async, when we are not calling it in an async context, seek, compiler, and code would do nothing and block on the blocking points. I mean, actually, we have a good example. Let me show you what's the difference. So you see that we had a blocking request in here and a some for loop in here. Sorry for the disruption again. Someone was at door. Okay, so we have a really crowded building. Everyone is coming and going, and also it's holidays of New Year in Iran, so it's even more crowded. So what I want to show you is that in this version, in the if we make this the sync version we had before, it would block on the it would block on this call and won't answer these. So let's run this, of course. Run this. See, it's waiting, and nothing is happening until this returns. So this means that async stuff is really good in Zig. I mean, you see that my code barely changed, and not the code itself, not the actual async function. It's basically my responsibility to make this async or sync. Just storing these frames would work. And this is a you know, maybe a bit complicated case. Most of the times you don't need to store frames for yourself, and you can just, you know, await, especially when you can await on stuff, because most of the times you have something like async function, and then you either store it or you await it. You can do something like this when you want a result. This is a specific case that you need to store the frames. Oh, and you see after this response, these came. So yeah, that is pretty much what I wanted to cover, what I wanted to reach in this video. Let's see a diff. We did a lot of stuff. Oh, actually, let me get back to the async version. And this. Okay. So I want to do git add and git commit. We should commit. We should have committed before, when we created a request stuff, HTTP context stuff. But adds HTTP adds asynchronous. It's a hard word to write. Async makes server async more structured code base. So we will have HTTP context type to represent each HTTP connection. So you see that we both use HTTP context to read the request and stuff and respond, and also call handle in an async context, so it's non-blocking, basically. Then git push. Okay. Oh, I did some README updates. Yeah. I did it using GitHub Web UI. So this is pretty much it for this video, I think, and it's actually a long video. It's hour and 20 minutes, I think. In the next video, I'm going to do, first of all, test how we are handling okay, let me just okay, I want to test how we can read the body from the request. Maybe in the HTTP context, I don't know if this is possible or not, maybe provide a good friendly API for the user, so the user can say what is the format of this request, and maybe the struct to fill, and we fill it for him, for the user. Yeah, so basically I want to provide a nice way for the user to bind its request body to a struct or type. That's one thing that I want to do. And second thing I want to do is to make start working on this part. So we already have the library part, right? We should of course make this main bit. This shouldn't be in main. This should be probably some kind of another struct for server, maybe called HTTP server, that has an init function, takes an allocator and some configuration and does all of these. And then we should think about that configuration. Next, we would go for routing and defining custom handlers for each route. Okay, we will do these in next video. Thanks for watching. I wanted to point out that I'm really new to Zig, so my explanations are probably wrong. But these are my understandings, and if actually someone knows, knows where I'm wrong, please mention it to me. And that is it. Thank you. If you like this content and these kind of contents, please subscribe and like the video. That's it. Have a nice time and goodbye.